like, that's not too much time.
Yeah. All right. So let's go ahead and do the. This is the last part, doing the significance testing. Now we're going to do significance testing.
No fun.
Okay. So you go to page 782. The bottom, it tells you how to find the standardized test statistic. So this is like any other significance testing, right? You have to find the test statistic, and then you have to find usually it's going to be the TCDF, right? And find out what the p-value is, compare that to the alpha, same old stuff, right? Same old stuff. Okay, so this test statistic T is going to be equal to the B. T is going to be equal to your test statistics going to be equal to the B1 minus whatever slope that you thought it was going to be, right? Over the standard error of B1, right? Okay, this is how you're going to calculate it. If you go to page 783, says suppose the conditions are met. So conditions are the same, right? Conditions for inference, whether you're a confidence interval or you're a significance testing, are the same. So you're going to go with the liner, right? You're going to use the liner. So suppose the conditions are met. To perform a test of the hypothesis, Ho is going to be beta 1 is equal to the hypothesis slope. Okay, so if it was whatever it may be, if it was 1.5, it's going to be 1.5, right? And then you would do the test statistic, okay? Because your B1 is not necessarily going to be equal to the beta 1, correct? Find the p-value again, calculating the probability of getting a same thing. You're still going to use the degree of freedoms of n minus 2. And go ahead and compare it to the alpha. And then either reject or fail to reject the whole, right? Okay, so let's go to the example, crying and IQ. Infants who cry easily may be more easily stimulated than others. This may be a sign of higher IQ or just likes to cry. Child development researchers explored the relationship between the crying infants 4 to 10 days old and their later IQ test scores. A snap of rubber band on the sole of a foot. Man, this is some cruel stuff. And show the intensity by the numbers of the peaks. Wow. The most active 20 seconds. They later measured the IQs 8 to 3 years. Okay, the table contains a sample. Okay, so the count, so versus the IQ. So you have L1 and L2 there. How many people are there? How many babies are there?
38.
38? Did it tell us? Or did you count them?
38.
You counted them?
At the bottom of the paragraph.
Oh, 38 infants. Yeah, okay, there you go. 38 infants, okay? All right, so flip the page. Here's the computer output from the least square regression analysis. Blah, blah, blah. So let's go ahead and check this.
What parents agrees to this?
So your whole is beta 1 is equal to 0. 0 meaning there's no relation, right? It's B is what? It's the same no matter what, right? Whether you are high IQ or low IQ, it still hurts. So they're still going to cry. Okay, so this is it. Your ha is that actually no, there is a positive correlation. In other words, right? The more you cry, the higher your IQ is going to be. Okay. And okay, did it give us an alpha level, or are we just going to go with 0.05?
0.05.
Okay. There is no.
It's at the top of.
Oh, is it at the top? Okay, so alpha is 0.05. Okay, so this is the state. Then the plan is liner, right? Linear, is it linear? Which graph are we looking for linear?
The thing, line.
The one on the top of page 780 for the left-hand side, correct? Okay, and then it's independent. Yeah, each kid is independent. They're different. Okay. And then normal. Is it normal? Let's look at the histogram. Looks pretty normal to me. Don't see any outliers. It's pretty, pretty symmetric. And then equal standard deviations. We're looking at the residual plots there. Look pretty good there. And we are random, so it says it's a random sample, so we're good. State plan, do, so we'll actually do this now. What do we need? We need the test statistic. What is the test statistic here? The T is going to be 3.07. Where does that come from? Comes from the table right there, right? Where it says the cry count 3.07 right there. Okay, the cry count is 3. T is going to be 3.07, right? Okay. And how do we find the p-value? Okay, let's get the p-table. Is equal to 3.07. We're at T3 and we are at 5%, 95%. And what's our 36? What are we doing here? Oh, we have to find the TCDF, don't we? Using the 3.07? What is a TCDF?
Oh.
3.07 to 100 with a degree of freedom of 36.
I'm
3.07.
the lower 3.7.
I got 0.002.
0.002.
So you can just
Same here.
the
Yeah.
P thing you divided by.
Yeah. Or you can do it that way, right?
That's great.
Okay. So it's 0.002, right? So your p-value was 0.002. Okay. So p-value is less than alpha. Therefore, we reject the ho. We have convincing evidence for the ha, which means that yes, the more you cry, higher your IQ. So this doesn't mean that you can, whenever you see a baby, you can do this now, okay? Oh yeah, I learned this in statistics. Yeah, let's try this. Okay, all right. So if you go to page 785, it tells you how to do this using your calculator. Okay, we're going to do the stats test, and we're going to look at Lin-Reg t-test instead of the Lin-Reg t-interval. We're going to do the t-test.
And it actually take that p-value and divide by 2.
What?
It's crazily accurate to just take.
Yeah, I know. Yeah. Because it makes sense, right? Because normally it would be two-tailed. Now you're looking at only one tail.